Assalamualaikum warahmatullahi wabarakatuh. Miss Viola and my friend, we are from Group 2, will presentation material about high-rise building of Material Clock Tower. But before, I will introduction member of Group 2. I'm Dhoni Batista as moderator and speakers 1, Moch Fatkurrohman as speaker 2, and Fitrotun Najib as speaker 3. Before present, let's pray together. Finish. Straight away, I will introduction to high-rise building project. My group calls Material Clock Tower, which is location at the heart of Holy Islamic City Mecca, is a complex of 7 buildings, of which the clock tower stand out in the center of the complex called Bridge al-Bait. 6 small skyscrapers surround it at various height and adapt to both residential and hotel application. Construction timeline. In 2002, the project of Material Clock Tower was designed. Then 2004, start construction. Then 2012, the construction was complete. In same years, the building opened. Location of Material Clock Tower is a part of a bridge Albert complex. The complex is meters away from the world's largest mosque and Islamic mosque is a site, the Great Mosque of Mecca. Next. And the building using architectural style postmodern neoclassical. The Material Clock Tower is stand out in the center of a bridge Albert complex with total floor space 15.6 million square feet, total height 601 meters, building deep, hotel, residential, high-rise complex, total floor 120 floor above ground and 3 floor below ground. Next. All companies involved: structural engineering, architect, and map engineering using Dar al-Handasa Share and Partner, development and construction using Saudi Bin Laden Group, material supplier using cladding using Gurit and Goodman AG, construction hoist Alimak Hack, crane crane system, elevator Kone, fine or coating Jotun, sealant from Dow Corning Corporation. Other consultant facades using curtain wheel design and consulting, like using Barton Beck and Van Hollen Richard Tech, Wind using Alan G Development Wind Engineering Group. Next. Material Clock Tower designed by Al-Handasa Share. The building was originally planned to have a height of 734 meters in 2006. However, in 2009, it was announced that the building would be 601 meter height. The building using decorated 2 million lamp. Okay, structural detail, David in 3, transfer floor, typical floor, and top floor, tower top, tower upper detail. Material Clock Tower cooperated with other well-known skyscraper, the third tall. Material Clock Tower cooperated to other tall clock tower in Norway. Main construction material, low apart using pure reinforced concrete construction at level 347 using a fire-resistant composite steel concrete construction to reduce the self-weight. At level plus 513 of tower is executed as the pure steel construction. Dimension clock measuring dial 43, decorated. The color clock was illuminated by the total about 2 million lit. And the clock facade is 35 times larger than those at London Big Ben. Next. Technical data, style construction using 12,000 ton style, mosaic using 98 million glass mosaic, cladding using glass, marble, natural stone, carbon or glass fiber reinforced plastic, composite using 600 glass fiber reinforced, Java using 3000 meter square glass, Crescent using 1050 meter square gold mosaic. This is photo of the material clock. The reason why my group calls the project of material clock because the building is very interesting to explore, known as the third tallest building and five tallest freestanding structure in the world. The material clock tower are a part of the King Abdulaziz Endowment project to provide accommodation, especially for Muslims to travel to the city very years during the Hajj period. Something really special about this building has a giant clock. This makes the Imperial Clock Tower become one of the most spectacular buildings in the world. Will then be continued by Fatkurrohman.
Two high-rise building structural system. It is picture of sub-drawing and detailed engineering design. The type of high-rise building structural system. Rigid frame structural system. Basically, in rigid frame structure, beam and column are constructed monolithically to withstand moment imposed due to loads. Technology used in the rigid frame structural system. A rigid frame structural engineering is the load member skeleton constructed with strict or curved members interconnected by mostly rigid connection with resist movement induced at the joint of member. Consists of column and girder joined by moment resistant connection. The use of portal frame, which consists of an assembly of beam and column, is one of the very popular types of branching system used in building design because of minimal obstruction to architectural layout created by this system. To attain maximum frame action, the connection of beam to column are required to be rigid. Rigid frame structural system. Beam and column. Beams and columns are constructed monolithically to withstand moment imposed due to loads. The lateral stiffness of a rigid frame depends on the bending stiffness of the column, girder, and connection in plane. Suitable for rigid frame structural system is suitable for reinforced concrete building. Maximum beam span. The maximum beam span is usually 12.2 meters. The larger span beam will cause lateral deflection. Size of column and girder. The size of column is mainly controlled by the gravity loads, and the size of girder is controlled by stiffness of the frame in order to ensure acceptable lateral sway of the building. Sorry, 20 to 25 or more story building can be constructed using rigid frame system. Advent of rigid frame structural system is easy of construction. Labor can learn construction skill easily. Two is durability. For modern structure, rigid frame is almost always the choice with durability in mind. Three, versatility. Rigid frame structure offer up to 300 feet of clear space with a completely column-free interior. And the disadvantage of rigid frame structural system is that the self-weight is resisted by the action from rigid frames. Price. The only major modern drawback of rigid frame building construct is price. Price per square foot is significantly higher than for asset style. Span length. Span lengths are usually restricted to 40 feet, when normal reinforced concrete, otherwise span greater than that, can use lateral deflection. Why our group choosing this structural system? Reason relate of choosing a rigid frame structural system for our building is because of the design of the building has glass window, which is ordered to see the view of the city of Mecca. This frame structure system resists shear, moment, and torque. This frame structure can understand flexible moment, sliding style, and axial loads, has the best durability among other structural systems. Therefore, this structure system is very appropriately applied to our building. 3. Substructure of high-rise building. Substructure of the building. The substructure is the part of the building that are located below ground level. The structure below include the foundation and slab. The type of foundation that is often used for high-rise building is a pile foundation. Pile foundation are one type of foundation that is commonly used to build small-scale houses or large buildings such as offices and hotels. Pile as the main foundation is also known as reinforced concrete pile, which is a reinforced concrete material with excellent strength. Type of the pile foundation. Friction pile. Friction pile foundation are used in soil structure that the sufficient hardness. The installation of the friction pile foundation is by beating into the ground using a machine until it sticks to the hard ground. 2 is bore pile. Bore pile foundation is used in soil structures that are muddy or that have less dense soil hardness. Method of implementation of pile foundation. Determine the dimension or size the pile, preparation, appointment process, the erection process, and last is quality control. This is step of determine the dimension or size of the pile. And this is step of preparation. Step of appointment process. The step of direction process, and the last is step of quality control.
The next is analysis related to the substructure. The substructure of the concrete stack foundation has two ways of installation, namely using the foundation of the manufactured stack and using the costed pole foundation in the place. Every way has advantage and disadvantage. The precast reinforcement concrete piles. It have advantage and disadvantage. The advantage is because the stacks are made in the factory and through strict quality checks, the result will be more reliable. The time required to perform erection is relatively fast, especially for steel poles. And the disadvantage is if the erection work is not done properly, the head of the pole is quickly destroyed. If the erection cannot be stopped at the predetermined depth, special repairs are required. It takes a large enough place to be used to accommodate stake machine edge. For steel stakes, corrosion-resistant poles are required. Cast in situ reinforcement concrete piles have advantage and disadvantage. The advantage is this type of foundation is suitable for work in densely populated area because at the time of carrying out the work there is only a very small vibration and noise. Usually, the diameter of the poles is larger than the precast pole or factory production. The third is because the work is minimal vibration and noise, so the adverse influence on the nearby building is quite small, and the disadvantage is concrete from the body of the stage made is in the ground containing water so that the quality of the pulp produced is lower than the precast pulp or produced in the factory. In addition, quality checks can only be done indirectly. Because the size of the pole diameter is quite large, require a lot of concrete, therefore for small work can cause high costs. Other information related to substructure in the implementation of erection is generally fastened perpendicular to the ground, but there is also a slanted to be able to withstand the horizontal forces that work. The foundation of the pole is classified based on the quality of material and the way of implementation. According to the quality of material used, the stacks are distinguished into four, namely wooden stacks, concrete stacks, steel stacks, and composite stacks. Uh, and the fourth is upper structure of high-rise building. Upper structure of the building. The upper structure is the part of the building that are located above ground level. The upper structure includes beams, columns, windows, floor, doors, the roof, finishes, and anything else. The part of the upper structure is the first is column. Column is a compressive structure element that play an important role in a building. Beams. Beams are also one of the reinforced concrete jobs. The beam is a structural part that is used as a floor holder and to tie up the column to the upper floor. The third is floor. Floor slabs are floors that are not located directly above the ground, so they are level floors. This floor plate is supported by beams that rest on the column of the building. Roof. The roof is the uppermost part of a building, which protects the building and its occupant physically and metaphysically. Shear walls. The shear wall is a thin cantilever beam structure that is slender vertical to be used to withstand lateral force. This is the method of implementation of upper structure. The first is ironwork, the formwork, casting work, and the last method of implementation is dismantling of the formwork and curing. Ironwork have three steps. The first is ironwork on column. This is the step by step. The second is ironwork on beams, and the last is ironwork on plates. Formwork. This formwork is very important job in the whole series of concrete works. The function of the formwork itself is to determine the composition, size, and shape of the concrete which will be casted to fit the dimension plan on the shop drawing. This is the following general requirement of the formwork. The third is casting work. Casting work have three steps. The first is preparation, the second is slump test, and the last step is casting. This is the picture of casting work. Casting on columns, casting on beams and plates, and this is the concrete prebator. The final method of implementation is dismantling of the formwork. Dismantling of column formwork can be carried out 12 hours after casting. The most extreme condition for columns formwork removal is 8 hours after casting. The removal of the formwork must obtain prior permission from the project supervisor. The process of removing the formwork is done carefully to prevent the column from being damaged. This is the step-by-step in dismantling of the formwork. The last is curing. After 12 hours of casting, the formwork column can be removed. The concrete curing process is carried out using the ultra-champ curing compound. It is the ultra-champ curing compound. Analysis related to upper structure. Podium to hotel tower for column, beams, plates, and walls using reinforced concrete, which is lined with cladding in the form of marble, natural stones, carbon fiber, plastic, and glass. The function of cladding is to protect the walls of a building from exposure to heat, rain, wind, and also dampen the noise. The top royal floor used steel or concrete composite. Maka Royal Clock Tower consists of 120 floors and is equipped with 96 lifts to support the movement of tower residents. Other information related to upper structure. The column uses square reinforced concrete and has at least 4 reinforcements according to the minimum thickness of the floor plates generally range from 1 per 30 to 1 per 35 of a short span for the focus of the beam on the both sides. The beam is planned to withstand the compressive stress and tensile stress caused by the bending loads that work on it. Due to the, due to the nature of concrete that is less able to withstand tensile stress, concrete is reinforced by steel reinforcement in the area where the tensile stress works. In addition to the flexible force, other things that must be considered in the planning of the beams among other are the shear capacity, deflection, cracking, and length of the channeling that must comply with the requirement. That's all for me.
Okay, all speaker have presentation. I represent group 2. Apologize if there is an error in the presentation. Wassalamualaikum warahmatullahi wabarakatuh.